A lot of these on paper advantages that I think non-light water reactors have, sometimes when we try to build them like anything else, it turns out they don't really materialize. And what I worry about here is the opportunity cost. We do have technology that once it gets built, we will have a high capacity factor and pretty good O&M.
The utilities, the state regulators, and frankly, as far as I can tell, Westinghouse are all saying, yeah, we don't want to do this unless the federal government is literally going to take on virtually all of the risk.
A warm welcome back to Decouple. And I think I have a very special episode for Decouple listeners today. There is obviously a spirited debate underway about the best approach to rapidly and effectively deploy nuclear energy. And we spend a lot of time talking about that here on Decouple. Because the question, to sum it all up, is should the future lie in advanced Generation 4 small modular reactor technologies like high-temperature gas reactors, molten salt, and liquid metal? Or is the fleet deployment of standardized, conventional, large-scale light water reactors the way to go? Today, we're going to be hearing from two prominent thought leaders on this issue. Ted Nordhaus is founder and director of the Breakthrough Institute and a vocal advocate for advanced and small modular reactor technologies. And James Krellenstein is co-founder and CEO of Alva Energy and a champion of fleet deployment of large light water reactors. Today, I haven't thought of structuring this as a formal debate, but I think rather an open and I hope constructive conversation amongst colleagues. As Decouple listeners know, I'm not exactly the most neutral of arbiter on this issue, as I've extolled and platformed guests supporting the large is beautiful perspective. So I'm particularly grateful, Ted, for your participation today, and I'll do my utmost to be a neutral and gracious host to this discussion. I think long-form podcasting offers a unique opportunity for much more civil and productive dialogue than is available on Twitter, and I'm really hoping for respectful and meaningful exchange here. Given past heated discussions between you two on platforms like Twitter, I'd just like to start by offering a chance to clear the air.
Yeah, no, and I thank you, Chris, and thanks, Ted, of course, for joining this discussion. I know we had a sort of tete-a-tete on Twitter or X, whatever we call it nowadays. And
let's just stick with Twitter.
Okay, Twitter, and I think it was about a response to your regulatory piece. And, I think obviously there's still some substantive disagreements, but, I think I made a certain tweet about how that some of BTI's advocacy may be motivated by fundraising interest rather than being, genuinely motivated. And I think that was unfair. And I just wanted to use this time to say, and hopefully to engage in that substantive discourse without us, resorting to ad hominem or in any other way. And so I just wanted to thank you for being here and hoping that we can have a productive discussion, maybe not even a debate, but even find some areas of disagreement, but hopefully areas of agreement as well.
I hope so, and I appreciate that. I can assure you that, becoming a nuclear advocate in 2011 was not a very good way to raise money from environmental philanthropy, and frankly, it still isn't. So I appreciate the recognition that we may have substantive differences, but I think I do believe they're on both sides in good faith, and hopefully we'll find some common ground as well as achieving some disagreement, as we like to say at Breakthrough.
Yeah, I look forward to this.
Okay, guys. So I guess by way of introduction, I think we've really seen back and forth in the last little while, some ups and downs, some hills and valleys. The release of the DOE liftoff report, I think, was a real swing towards this idea again of deployment of conventional large water reactors, nominally the AP1000. I think mentions of the AP1000 went from 1 to 43 between the 2023 version and the 2024 update. But momentum seems to be swinging back now more towards Gen 4 SMR viewpoints. Tech companies like Google and Amazon announcing PPAs and even, I think, direct funding in the case of X Energy and Amazon for Gen 4 reactor vendors. As far as I know, there's not been any agreement signed or even publicly discussed around AP1000. So momentum seems to be swinging back. Maybe, Ted, if you can start by updating us on the latest developments and why you think the pendulum might be swinging back towards advanced and small modular reactors.
I mean, mostly because no one wants to build, no one in the U.S. electricity sector, utilities, vendors, state regulators is willing to take on the risk of, betting, 25, $30 billion, give or take, to build a couple of gigawatts of, you're not going to build one AP1000 at a time. You're going to build at least two of them. That's a huge lift. Even in kind of really, frankly, the only place that anyone's going to do it, certainly in the U.S., which is in vertically integrated, sort of cost of service, traditionally regulated monopoly utilities, where you can rate base the cost and sort of pay these things off over 30 or 40 years, for a piece of infrastructure that's going to last 80 years. I think that large reactors really are best thought of as, very, fairly extensive, long-lived public works projects. We need to think of them as infrastructure, not as discrete technology. The U.S. being sort of in this weird bubble of the 60s and 70s, like the one place in the world that ever tried to build infrastructure in this way privately, ostensibly privately. I use the term advisedly. But kind of everywhere else in the world, nuclear fleets, large reactors are built by vertically integrated, usually national, or at least national scale, if you go to a place like China, publicly owned utilities. And, the kind of developer, vendor, whatever label you want to put it on the other side of that is generally, some form of a state-owned enterprise that, in many cases is building a single design over and doing all the things that James and everybody going back a long time has argued. And I think if you just look at the reality on the ground in the United States, where we have, I just Googled it before I came on here, I think like over 2,000 utilities in the United States. You've got 70% of electricity demand in the US served by one form or another of liberalized utility market. All of the conditions that we know kind of go along with this quite remarkable, large piece of infrastructure mostly don't exist. So if you want to go when a Google or an Amazon looks at what sort of bet it's going to make on nuclear, there just literally aren't the institutions, the conditions. You can kind of reduce it to sort of this thing called policy, but you just don't have literally the institutional context in which anyone could do this. And, having listened to a couple of James's podcasts before I came on here, and James sort of made this point, don't sort of solve a financing problem with an engineering solution. You still have to solve the financing problem. And it's really not just a financing problem, it's an institutional problem. And frankly, and my kind of biggest criticism going back a long time before I even knew who James was, but there's always been a camp in this sort of nuclear advocacy community going way back that just build large reactors. Chris has come around to this, but even, before you, Chris. And the question I keep asking people is, okay, who, how, what is your proposal to go create the institutional conditions in which it would be feasible to go build 10 or 15 or 20 or 50 large reactors in the United States? And I hope maybe in this conversation, we'll get a bit more clarity from either of you as to, maybe in Ontario you can do this. You could still arguably maybe do it in France. You can obviously do it in China. But, my question to all of the large reactor advocates is, what is your proposal to create the institutional context in which the scale of build out of standardized multiple builds of large reactors, many, many gigawatts of capacity can happen? because literally we don't have the institutions right now to do that.
I think it's a great point. And I think that, to undersell the challenge here from a financing perspective, from a risk allocation perspective, and even from, to use your term, an institutional perspective, if you do that, you're kind of losing the plot here, because in so many ways, I think SMRs and the sort of non-light water reactor technologies, at least on the smaller side, are really in many ways a solution to a real genuine market demand that you've recognized, that I think that has been in the utility industry, not just since Vogel and Summer, but of course since the failures that happened at Whoops, at Seabrook. I mean, we could go down the list, unfortunately, of this industry's failures. But I do think that there are models that we have seen internationally that are allowing deployment of large light water reactors into fully merchant markets, right? And these are, of course, to your point, Ted, none of these are operating as merchant generators. But when we look at what the two largest light water reactors that humanity's ever being built right now in the United Kingdom, right? Obviously, the UK is the sort of after Chile, right? It was the first market to fully deregulate, right? We saw that in 1989, and we're obviously building Hinkley Point C right now, which is a massive project in a fully deregulated market, right? And we're doing that through a contract for differences, approach, right? That EDF on one hand, as the builder, is doing, but using basically and the Chinese are also putting financing in. They are deploying this reactor technology into a merchant market, in a fully liberalized market. And same thing, of course, happened already in Finland with TVO, building Olkiluoto unit number 3, right? Once again, in a fully merchant market using the Mancala model, with sort of a consortium of direct industrial off-takers with firm price PPAs. And I think one of the things that you put recently in the piece with Adam Stein that I thought was really a great point is that the opportunity that we have with the large hyperscalers to basically be counterparties for a large amount of industrial offtake, right, at a firm and high fixed price PPA, is exactly the sorts of models that we have seen that have enabled large light water reactor deployment in merchant markets outside of the United States. And I think one of the things that would be a really interesting discussion to have today is to talk a little bit more about, do you think that model that is compatible with something like a large light water reactor, whether an AP1000 or an ABWR or something else? And I think maybe in order to have this discussion, I think maybe we have to go back up, which is, why are we actually having this discussion about large LWRs versus SMRs or microreactors or non-LWRs, right? What exactly is the motivation for going large, or in your case, going small, right? Or getting away from water and not, or as a moderator and a coolant. And I think that is, I don't think we can have this discussion almost as, why would it be worth having, going big, if we don't actually talk about the merits and the upsides and downsides of that from a more first principles engineering perspective.
On some level, that may be a better conversation for you to come back on the show and talk to Adam Stein about. I think you and I come at these discussions, at the issues slightly differently. I am happy to talk about, at a sort of meta level, why I think that there are macroeconomic reasons why, particularly in the US, I think it's going to just be very difficult to move forward with the kind of thing that you just laid out, that is, similar to what the UK or Finland have done. I actually, again, having listened to some of your points, and I followed this stuff for a long time. I appreciate that, we can kind of get into the engineering of small reactors, and there's a lot of uncertainty. These technologies are less proven. We have some history going back to, mostly the 60s and 70s, a bit more recently, where people tried to do these things and it proved harder than people had anticipated. At the same time, I went and I like visited, Per Peterson's lab, at Berkeley, you know, 15 years ago when he was, working through how his cooling system, the cooling system that is ultimately going to be the Kairos cooling system was going to work. There's, um, different approaches that some of these different startups are taking. Kairos is going to go and build and operate small demonstration reactors before they try to do anything commercial. TerraPower is going to go build a pretty good sized for an advanced reactor, first of a kind reactor without actually running a demonstration project. And we're going to find out, what's going to work. In that sense, I think having sort of multiple firms taking different approaches is a strength, not a weakness. We're going to get kind of, more shots on goal, as they say. And they might all fail. And, I don't actually think that there's, I don't think that the obstacle to getting AP1000s built is the fact that, we've still put a sort of relatively small amount of money behind, public money and resources behind small, commercializing small reactors. I think the biggest problem is the thing that we started talking about at the top, which is, the politics, the policy, the institutions that are going to make it possible. I mean, I know people, I know several of my former staff were very involved at Google in putting together the Kairos deal. They went and took a hard look at what it would take for them to go do an AP1000. Without, sort of sharing anything that they said to me that, I think they wouldn't want me saying publicly, I think after doing a lot of due diligence, they decided that at least right now, given the current sort of political, economic context, it was not an option for them.
Yeah, I can't really comment about the Kairos deal or the Google stuff. I should disclose, I guess, we work very closely with Google and we have a paid relationship with Google. So for obviously confidentiality reasons, I can't comment on that specifically, but pulling back a little bit more, I think that we talked a lot, and I think it's an absolutely correct point about the challenges that we have with deploying large light water reactors in deregulated markets, or let's be frank, regulated, vertically integrated model. They're not flying off the shelf right now at Duke or Southern or TVA even. But I think, we're kind of hitting on the other side of that coin, which is when we think about what, the challenges that we saw in the first non-light water reactor deployments that we had in the US that were commercial and even demonstration projects, right? I don't think that that's like an indictment of non-light water reactors. I don't think that that means that a sodium-cooled reactor is inherently less reliable than a light water reactor or high temperature gas. We could go down this list. Right. But I think it is actually a similar financial or policy problem that we have, which is that, even the light water reactors took 3 decades, roughly speaking, to get to that 90% capacity factor that we sort of assume now is what nuclear energy is. And I think it's a similar sort of engineering challenge and a policy challenge of incubating Kairos, or, we can go down the list. I don't want to name any names because it's just to your point, we haven't built these before. So we can talk a lot about the financial engineering challenges or policy challenges, but it's necessary for the large light water reactors. And I think we probably agree that that's really going to be make or break them in terms of actually whether they're going to be deployed in the US. But what I would like to spend a little bit of time and maybe get your thoughts on is how do we think about when we have a non-LWR technology like a high temperature gas reactor at Fort St. Vrain that operated at a 16% capacity factor over its lifetime, or, a pebble bed reactor, or the, Enrico Fermi unit number 1, or Phoenix or Super Phoenix, we how are we going to actually make this bridge, right? Because as I think you have noted, and I totally agree, the thing that, the reason why nuclear has such a compelling value proposition to the hyperscalers right now is that it's firm, 24/7, zero carbon power at a very high capacity factor, which really no other technology can address. But that is not, I don't think, implicit in, it's not inherent in splitting atoms. That's inherent in the fact that we have a highly mature light water reactor technology that operates at a 92% capacity factor fleet-wide. That's not necessarily the case, I don't think, that we're going to get out of the non-LWRs, the so-called advanced reactors, on the first time. And that, in my mind, is not a reason we should abandon them. But what is the policy, the financing policy that we can talk about that allows those reactors to go through a 10-year or 15-year long sort of incubation period, for lack of a better term, that allows them to reach that high capacity factor?
Yeah, and I think that's, it's a great question, James. And, I think the interesting thing is that, certainly in the U.S. context, if you look at, and again, this is just like, if you just look at the sheer amounts of capital that anyone has to kind of put on the table, the amount of just of financial risk that anyone is taking. And I don't want to keep harping on the AP1000, but just that, it's like the thing that we know right now is that, like, basically even in, to your point, the Duke Energies, with, like, basically, they already have a kind of cost overrun insurance, which is essentially the ITC.
Absolutely.
Technically, like basically a third of your cost overrun is taken care of, as well as a third of your cost, of just your full capital cost. You're in a regulated market where you should be able to rate base it. Basically the utilities, the state regulators, and frankly, as far as I can tell, Westinghouse are all saying, yeah, we don't want to do this unless the federal government is literally going to take on virtually all of the risk. I think when you look at the Kairos deal, when you look at the Amazon deal with X Energy, just even like, let's just grant that these first plants are going to cost more. You can kind of go look at some of the, various analyses, come to different conclusions. But the truth is, nobody knows what any of it's going to cost until they actually build it. But, to some degree, these are well beyond the sort of kind of bullshitty MOUs and similar that we've heard about for sort of years in the sector. Once you're at, 150, 200, 300 megawatts, even if it's more costly, it's far, far more feasible to finance with project finance in the ways that we build gas plants and solar farms and lots of other things. I think that, the big question that everyone's talking about, and frankly, I think this is the case for whether it's large reactors or small ones, is that for anyone to actually kind of succeed at this at scale, they need to be able to build an order book where you can essentially sort of spread that risk. And in the case of these advanced reactors, all of the problems and challenges that you're going to have with probably the first couple of reactors over a lot of subsequent builds. Will that be sufficient to get anyone kind of through that initial commercialization phase where they have a reliable, economically competitive product? I don't know. And frankly, kind of, I don't know that I don't think the developers know. I don't think the folks on the other side of these deals know. I don't think Chris or James or any of us actually know until, like, someone gets in the middle of it, and maybe it's going to fail spectacularly, and maybe it's going to work, and it's probably going to be a muddle, and I think all of it's going to be a muddle. And so I'm very happy, like, if someone can kind of tell me a feasible way where we're going to go get 10 or 20 AP1000s built in the next, I don't think that's necessarily mutually exclusive to kind of what we're trying to do with small reactors, and I would support it. But I just kind of, I think one of the problems that I think is underappreciated in the engineering culture that we have in the nuclear sector is that the political and policy problems are not easy to solve either. And sometimes the way that you solve a political and a policy and a financing problem is through engineering, is through coming up with a different sort of mousetrap that is more, tractable, that makes the political and policy challenges more tractable. And I think that's why at least some of us have gravitated, who spent a lot of years doing policy and political work, and frankly, kind of stood up and said, hey, we need this technology when like literally no one else was doing it, have gravitated towards SMRs.
Right. And I think that's a really fair and level-headed analysis of where we are. I think maybe I'm searching for disagreement to make this, not,
Come on, guys.
Yeah, exactly. Well, the screaming fighting that I think
No,
we
I think
are all
James and I are pretty aligned. It's Chris.
Yeah.
Yes. I've been trying to get Chris into this
it's
argument
Chris,
from the
it's
beginning.
all about can do. Yeah, no. But let's. I want to though do dissect, and maybe I can actually generate some disagreement here and some drama. But I think here's where I come down is that at the end of the day, the Google, without sharing any anything, this is just all thing that you can read in the newspaper. The Google and Amazon deals, let's just put them together. Essentially what they are is, as there's obviously some investment going on that's I think very exciting and a very good thing, but they're essentially power purchase agreements, right, with a very creditworthy offtake, right, with people who that if you generate that power, the check is not going to bounce, right? This is not standard power. This is, and I think that we probably all both agree. I imagine all three of us agree that this is generally a very, very good thing for the industry writ large, because what we are seeing here is creating a market. I don't think that we necessarily know that the financing of these projects is going to be so easy because, when you think about a power purchase agreement without thinking about anything other than what a PPA is, essentially that is dependent on your ability to make the power, right? If you don't make that megawatt hour, you don't get paid for that megawatt hour. And if you're thinking about if you're a bondholder here, right, and you're thinking about if you actually start diligencing the track record of what a novel reactor technology has, I hate to tell you, I think that's going to be a really hard sell to a bondholder. And maybe this is where, of course, the LPO I think can really put a really important, that's actually what the statutory function of the LPO is to actually give that assurance to your bondholder that actually if the project just turns out to be a lemon, is running at a 20 or 30 or 40% capacity factor, that's what the LPO and the federal government's for. Getting, I think, that project equity, upfront capital necessary is going to be still quite challenging. But let me flip this around and ask you this question. So one of the things that we do know about the AP1000s, I would argue generally large light water reactors of the Gen 3 plus flavors, is that they have a lot of construction risk and don't have very much operational risk. I think we're kind of flipping. The sort of advanced reactors or non-LWRs and SMRs, I think we can sort of start flipping around and say, well, maybe they have construction risk, maybe they have operational risk, but ultimately the total capital outlay that you're needed to do to finance this is just going to be smaller because they're smaller plants in general. And I think that's really where we've come down in this, call it a debate, right? Is that smaller amount of capital, which is not turning out to be that much smaller, unfortunately, in a lot of these projects. But to your point, Ted, no one really knows what that capital outlay is going to look like for these never before seen reactors. In a world in which we are getting routinely prices above $100 a megawatt hour for nuclear offtake, where with that ITC and PTC, or ITC, you have to obviously elect, but let's say we elect the ITC, we know that we likely can build Vogtle at Vogtle costs, right? And actually deploy these reactors. And if we have credit-worthy offtake on the other side, forget about learning anything from Vogtle, all the screw-ups that happened at Vogtle. We can build it, and we know that we're going to get a product and a technology that at the end of the day is going to be able to deliver at a 90% capacity factor or 92% capacity factor pretty much on the first year of operation or second year if the Chinese experience and what we're seeing down in Georgia is illustrative. I would argue that that is going to be easier, or maybe a better way of putting it is it's going to be as challenging to finance as a novel reactor technology where you have both construction and operational risk. And I think that both of them are going to demand some policy support to get ourselves off of the ground. And I don't think that we actually have to make this, this sort of binary choice about, it's either, we're either building Ted's reactors or we're building James's reactors. I actually think that the policy support that we're going to need can be actually can be sort of technology agnostic. And I think that that's more of what I think we need writ large. And maybe where we disagree is that I think if we have that technology support, which is not, by the way, cost overrun insurance, which is the dumbest idea that I think anyone who knows anything about nuclear insurance knows that what cost overrun insurance is just a way for Bechtel to, or not Bechtel, or someone to figure out how to get that cost overrun insurance, right? There'll be a lot of people whose job it is to just get that money away from them. My question to you, Ted, is are we actually really solving the policy problems that we need? And I agree that Google and Amazon and other technology, off takers, this is fantastic news. I don't necessarily think that this is the end of the story that we're going to see with the hyperscalers to give, a very similar potential model as what we saw deployed in the UK and in Finland.
You might be right. We'll see.
This is not the drama that Chris invited us on for. No, I'm just kidding. Ryan.
I hate to disappoint. Maybe Chris is going to come and tell us how we're going to go build lots of can-dos in Canada.
Yeah, that's like can-dos everywhere.
To your point, we have a licensed reactor. We built one of them. They cost more than they were supposed to cost, but that's just how mega projects that's how you sell them. Everyone keeps thinking that this is, if you just take the mega project view of this, what we know about mega projects is that the way that you get a mega project built is that you underestimate its cost. And it's not just true of large nuclear, it's true of airports and rail systems, and that's part of the underestimating the cost is a feature, not a bug, if you're trying to build a mega project. But, we built the thing and it works and it's generating electricity and it's licensed, and we can point to, at least a handful of sites where you could kind of go do it again. We've got, these new technology neutral tax credits that frankly, kind of take care of at least a significant amount of the cost overrun risk without doing cost overrun insurance. We got LPO that literally has just put this report out. And I will just say that no offense to anyone at LPO, but it's like if you went back 2 years before, it's just all SMR all the time. And then basically, if I was going to be cynical about it, I'd be like, the NuScale thing goes belly up. And what I heard from one person at LPO is, 2 years ago, all the utilities in my office were coming into my office saying they wanted SMRs, and now they're coming into my office saying they want AP1000s. And I'm kind of like, well, I don't know. Why would you believe them either time? It's not that credible to me that this one project, which 2 years ago you could see that this project was in trouble. And then the people who told you that this is what they wanted now that it's actually publicly announced or back saying they want something else. And I'm like, that's not confidence inspiring to me. LPO is literally hey, we're here. Come, we will give you as much, we will move capital to you. Anyone who wants to build an AP1000, we are open for business. Come on in. And we're still waiting. And again, maybe, I keep hearing, you probably maybe even have more inside knowledge than I do, but, I keep hearing that there's a big announcement coming and, it hasn't come yet. So, I think it might be interesting to kind of go, well, what is the policy context, whether it's for small or large? What do we need? How does anyone kind of get enough of a committed order book sort of that you could really look at this and have some confidence that we're going to get to the other side of it with a lot of new nuclear? And
Well, yeah, I mean, I think one of the, and this maybe goes to something that we may disagree about, maybe not at all. I think one of the interesting things about deploying a standardized reactor technology is, hypothetically at least, and this is operative because it sometimes doesn't happen. You can get a global order book happening, and at least on the supply chain side of things, less so on the engineering and construction side of aspects, you really can actually start coming down that, or if you want to call it a learning curve, maybe that's not the right term, but actually just having an actual somewhat reliable supply chain, which was not the case when Vogel or Summer or Sanmen and Haiyang, at least in the first two units, were built. And I think that, for the AP1000 at least, you could say, well, we're going to have this Bulgarian project, which is running, right? That's a state-owned enterprise, obviously backing it. Same thing with the Polish project, also a state-owned enterprise, and possibly a Canadian large project that may or may not be, no one here, of course, knows anything about what technology is going to be chosen there. And all of us have been yelled at, I think, probably for daring to opine on what Canada should build.
I have not
But
opined at all on what Canada
yeah,
should build.
I have not opined either, but I've been collaterally yelled at by people in Canada about daring to be associated with what should be built or not. And I think that does give you at least part of the equation. But I think we should talk about what do we think is going to need to actually happen to come down, to get over that activation energy that will be necessary to whether that's I mean, you're absolutely right. There's no one coming to LPO. I mean, there's applications in right now at LPO for AP1000 projects. Let's see where they go. But there's also not any, conditional loan guarantees on the on the non-light water reactors either, right? And I think either way, both of us are having this argument, and none of us are really that further ahead of each other, right? But I do think that on your side, if we want to make this into a sides argument, we have at least public commitments from very creditworthy off-takers. And in one case, just doing the public information, we have money being spent, right, in order to develop those projects. And we haven't, to your exact point, we haven't really seen that happen on the AP1000 side yet. Now, if we rewound this clock 10 years ago or 15 years ago, right, we had huge amounts of money flowing into not just AP1000s, but EPRs. Thank God that didn't happen. ABWR projects, right, all throughout the United States, with huge amounts of money being spent, and probably something that you and I agree on, and the absurd amount of money it takes to basically get through the NRC COL process, right? And the absurd amount of time it takes to get through that process. This is not a trivial amount of investment on any of these utilities. And we saw gigawatts and gigawatts, in some cases, being licensed, or at least the applications were prepared in both merchant markets and non-merchant markets. Right, in ERCOT, right, we saw ABWR projects being built at South Texas Project 3 and 4, ESBWRs, right, big PWR projects being put together. And I think the question is how do we get back to there? And the most obvious answer is natural gas is not at, is at less than $3 or $4 at Henry Hub right now. And until we figure out if we want nuclear to deploy in there, how do we actually deploy both in the regulated and non-regulated markets on both the advanced and non-advanced side? And I'll go here one thing that I think is really, really critical. I think we do need to see some changes at LPO on parental guarantees, right? I think in particular, if we want to talk about project finance, and people at LPO are going to hate me, I don't really care about this, right? The idea of project finance, at least hypothetically, is that we take off the risk from the balance sheet of the ordering developer or utility and let that special purpose vehicle sort of stand on its own balance sheet and not necessarily have connections to anyone else, right? At least hypothetically. And we see this actually working a lot in this combined cycle gas turbine market, and of course in the renewable projects. Those are a lot smaller amounts of capital. To your point, they don't generally need bond insurance, but we do generally see, a special purpose vehicle being set up, an LLC, by a big Calpine or CPV that is getting some investment from PE investors, but ultimately there is a market that is financing that debt. And LPO, if you look at one of the original reasons why LPO was created in the Energy Policy Act of 2005, it was to solve this exact problem, right? Exactly how no one's going to buy basically debt that's coming off of a nuclear project that's not backed by a large entity's balance sheet, right? And obviously those entities don't want to actually put their balance sheet at risk because it is actually this high risk problem, which is in my mind what LPO was created to solve. And I think that right now there is a little bit too onerous of requirements that we're going to basically put the default risk back onto the ordering company's balance sheet. That is sort of something that I think government can solve, especially for the first couple of units. Now, we have to solve some political problems. If you think about what happened after Solyndra, right, it was a $500 million or $700 million default. In my mind, that's the exact point of why LPO exists, right? There should be more defaults actually than the current loan portfolio has. And I would argue that this is going to be really essential, not just for building AP1000s or ABWRs, or if we're really crazy EPRs, if we really want to kill ourselves, right? But it's also going to be really critical if we want to be able to deploy a non-light water reactor at Energy Northwest or anywhere else.
Yeah, no, I mean, I would absolutely agree with that. And, like I was kind of one of the people who set themselves on fire when it happened, defending the Solyndra failure. That the whole idea here was to kind of,
default, right? Risk.
To de-risk things that are risky. If you're de-risking things that aren't risky, you're not actually really doing anything. Yeah. I would agree with that. And, I'll say a couple of things. Just go back to a couple of other things you said, James, so on this issue of like the AP1000s and the fact that one way that the AP1000 kind of comes back to the US is that we go build some more of them in some other places where kind of, again, the institutional arrangements are better suited. And you get this sort of supply chains and various other kind of pieces of that puzzle, a bit further down the line. And that seems entirely like, yes, let's do that. Let's see if we can get the thing built in Bulgaria or, wherever.
Poland or wherever. And Ontario, maybe.
Yeah, Ontario. I think the second thing on the advanced and the non-light water, I mean, and we had some, I'm not really clear how big our differences on some of the regulatory issues are in that, really my main point there was actually there's this sort of claim that the regulation, that because costs were rising before 3 Mile Island, the NRC and the regulatory framework wasn't really a big deal in terms of cost escalation in the US cost history. And I think you actually basically agree that actually it did.
Absolutely.
I think where we might part company is the degree to which that then got fixed or got resolved in Part 52 and some of the things that happened post 3 Mile Island at NRC. But, the one thing when I look at small advanced reactors and when I kind of look at the mental model that I think most people have for how this is going to work and how they get economically viable and competitive and cheap, and obviously there's sort of basic operational things, but there's if you kind of go to what the mental model is, it's there's a factory somewhere, right? And there's an assembly line and we're cranking these things out one after another and we're getting all of that good technological learning and we're doing process innovation and we're managing, we're being super flexible, just in time, managing our supply chains like Toyota did in its heyday or, whoever. And I do not believe, and we are not remotely close to a regulatory framework that could ever actually accommodate that. And so when I kind of go, what is the other thing that I kind of go okay, Kairos or X Energy or, get this first thing built. And it's kind of we know it's going to suck, right? It's going to cost more than it's supposed to cost. It's not going to work that well. And then, they're going to, and if they're done what they're trying to do, they got 20 more they're going to build. And then it's okay, so to what degree are they going to kind of have the sort of flexibility, within the regulatory paradigm to be like, okay, we're going to kind of, we're going to move our graphite bricks around or whatever, or we're going to kind of reformulate our coolant, our salt coolant a little bit, or, we're going to change the shape of, the diameter of the reactor vessel, without like
5 years of regulatory delay.
And so for me, like, when I look at like the things that hang up this vision of this small, advanced, next generation, innovative, and we're going to get way more learning and all of that, that's like the biggest thing. And then can you go in and can you manage, can you switch suppliers,
So I think we probably actually agree on that. I think maybe where we disagree and it's sort of like the way that I think of, to use a totally overused example, but I'll just use it one here, is like where SpaceX is, right? Like I don't think the problem back in 2014 or 2015 with the sort of orbital launch market was the FAA and the regulations that are associated with it, right? It was really that we had just huge incumbents that were really bad at sorry, my headphones just fell out, at the technology and so on and so forth. But eventually right now we are actually seeing that things like NEPA and other things, right, are really actually coming now without that we have a highly mature industrial ecosystem that is producing, launching every other day or every 3 days, right? And I imagine that's actually probably what would happen with the Nuclear Regulatory Commission at a certain point where we get to that commercial level of factory assembly, if that is in fact where we end up, right? I think to your point, we are not set up, the NRC is not set up, even though they have allegedly a manufacturing license process. We know from a practical perspective, the NRC is not set up for that sort of level of mass production of nuclear power plants right now, or nuclear reactors of any sort. I think maybe where we diverge on this point is two questions. The first is that right now what is holding up the advanced reactor market, right? In other words, are we not seeing Hermes 1 and 2, which has construction permits now for over a year, making substantial progress because of regulatory hurdles that have happened? And then the second thing is, on the sort of factory assembled perspective, right, are the reactor designs that we have right now are amenable to actual significant shifts of the capital cost structure of that plant being shifted off-site versus on-site? And I think one of the things that if you start looking at where the designs have ended up, particularly to your point, maybe in the light water reactor space, on the small modular side, right, we're actually coming up with these designs where more work is being done on-site, or at least a comparable amount than an AP1000 or an ABWR. And we could maybe have an argument that that's actually maybe a consequence of regulatory stuff. Certainly in NuScale's case, I think you can make a very clear argument that the reason why the NuScale reactor building is so expensive and so big is the aircraft impact assessment rule. But I think
the gigantic bathtub was basically completely insane.
Absolutely crazy.
The
right? And larger than an AP1000, right?
A small modular reactor has larger civil works than a large reactor. That's insane.
Or the BWRX 300, which is my favorite SMR, by the way, and I still think is a great product. But this is not a tiny, little civil works that's being done. I think the AP300 is going to come out that same way. But I guess my question goes back to there are inherent economies of scales in nuclear engineering. There's a debate about where you actually hit, some optimal point. Do we really? What are we imagining the factory fabricated sort of reality looks like? And I think it might be there, but how do we get to that point where the technology is mature enough that we can actually really start putting the capital investment into a factory, not as a factory, but a sub-supplier ecosystem that's supplying those components?
You have to know what you're building and how you're building it.
Precisely.
And be pretty confident in that before you can do that. Absolutely.
And so how do we get, and I guess maybe going back to, rather than having a debate, maybe the question is like, how do we get to the point where we've done, tried out a couple of designs, iterated, and maybe we do need to go out of the NRC paradigm for that, go make the DOE sort of test reactor paradigm and authorization process much better. I don't think it's very good right now. I don't think that particularly the Marvel experience is giving us any faith that's any better than what the NRC is doing. But how do we, one, get the regulatory paradigm, to your point? But second of all, how do we get the financing of that? Because it's going to be, the idea, of course, as you noted, is you're going to build one advanced non-light water reactor, and then you want to build 20 more. But I think it's going to be hard to go to bondholders or investors and say, well, the first one is operating at a 45% capacity factor and was 50% more expensive to build, now giving the financing to build the next 18, right? That's, I think, as big of a challenge as after Vogtle happened, Westinghouse just thinking that bondholders and investors and public service commissions were going to be like, oh yeah, and we'll just now build 5 more after you win, double the price and double the schedule. So I think that we're kind of actually trying to solve for similar, if maybe different problems there. And the regulatory thing, I think, is going to be a challenge. Maybe my argument is that it's not the primary challenge that we're facing right now in the space.
Well, let's just kind of go to like the example you gave, which is Kairos. And I think it was very smart on Kairos's part on one level. That, Kairos was like, we're going to go give the NRC what it wants. Because what the NRC wants is for them to go build a demonstration reactor that's not connected to the grid and operate it for 2 or 3 or whatever years and give them a bunch of data and then say, okay, now license our commercial reactor. And, what I think was very smart in the way that they did that is that they went, okay, if that's actually our strategy and our, if you could contrast that with Oklo, where it's like, we're going to kind of build the smallest, most like kind of ostensibly low risk, in terms of public safety reactor that we can think of is going to be like a 1.5 megawatts. And we're going to just kind of like go and say like, okay, we don't need to do any of the things that you normally do. Because we're so small and we're so safe. Well, good luck with that. That didn't go so well. But, and kind of Kairos does the opposite. Kairos says, we're going to give you everything we want. We're going to build a demonstration reactor. We're going to operate. We're going to give you lots of data. You're going to license it. And we're going to kind of use that, to kind of essentially go sort out our supply chains and a bunch of our systems. And we're going to kind of work out a bunch of the bugs before we actually try to build a first commercial reactor. And so, I think that when we point to the progress that has been made there in the licensing, it kind of goes like, this is like the best case, right? I think we're going to find out as, TerraPower, Oklo, the others that are trying to go straight to a first of a kind reactor, how that goes at the NRC and the degree to which we really are moving towards a better, more efficient regulatory paradigm there. And I think we're also, we may also find that out when Kairos tries to go from
a construction permit to an operating
this first
license.
demonstration, right? Yeah, and
or even getting the FSAR in. I mean,
tries to scale to 150 megawatts from 15 or whatever it is now.
Oh, I totally agree. And searching for a little bit of disagreement between us, and maybe where I'm going to try to find maybe we'll disagree here. I think maybe my disagreement is that I think Kairos's strategy is not just brilliant from like a regulatory and politics perspective. I think it's really smart from an engineering perspective too. Because what they're basically saying is, okay, let's build these test reactors, not only because, we'll make the NRC happy, we'll use 1537 rather than 0800, all that sort of nonsense, right? But also because, I think Kairos is pretty public about this, that if you ask them what does their design of their commercial reactor look like, what they'll tell you is like, we don't really necessarily know because we're going to get a lot of data and a lot of insights out of those test reactors. And we're going to take that and then build a power reactor that's a commercial product that is going to be designed to develop. And I think it's a brilliant strategy. And I think that they do this because a lot of it's NRC sort of, it's good NRC politics. To your point, it's what the staff wants them to come in and say, we're doing a test reactor. It's not a commercial reactor. It's small. It's 35 megawatts thermal. But I think that's really smart from an engineering perspective as well. And I think TerraPower, what I worry about with TerraPower is not necessarily that they're going to have that huge of a problem with the NRC, although famous last words. It's that, what is the reactor that they're going to build at the end of the day going to be, especially considering they're not using it as a breeder reactor, they're not using it as for fuel cycle services. But if we look at the history of where sodium reactors are, is that going to really be cost competitive with a light water reactor, both in terms of just capital cost economics, as well as, of course, operation, a capacity factor and something else. And, if you have Bill Gates backing you and Warren Buffett, this is a little bit more amenable for that first reactor. But, to your exact point, it's not about getting the first reactor built. It's getting the 10th reactor built. And what keeps me up at night on the advanced reactor side is, what is the strategy that we have to get not to the first build, but to the 10th build, acknowledging as we do, that, we're going to have a lot of challenges, operational challenges in the first couple builds.
Yeah, no, I mean, I think that is, on multiple levels, sort of the finance, the operations, and the regulatory and the supply chains, all of those things are big challenges and unknowns and uncertainties. And, to be clear, if you go talk to someone like Per Peterson, what he will tell you is no, this has our approach has regulatory advantages, but he would say, we're not doing it for the regulatory advantages. Now, I don't entirely believe Per, but I take his point, which is that there are other very good reasons that they have chosen that approach. And I have similar concerns about TerraPower. It's just a big ass piece of very complicated machinery that, we really haven't built before. The interesting thing, when we kind of did some modeling a few years ago, which was used in, the LPO report that was all gung-ho on SMRs, when that was the kind of the idea of the moment there.
Flavor of the week.
Exactly. But, a reactor that looked much like the TerraPower reactor actually was the thing that the model wanted to deploy because it had sort of storage and the ability to kind of load follow up and down. Now, when you're procuring for data centers, it's a little different, although it really isn't, because of the kind of mechanics of where you're actually selling the electricity as opposed to how these deals work, because you're not actually, at least in these initial deals, literally sending the electricity
on the bus bar
to the data center. So, it's interesting, that reactor. And then you kind of go well, how much harder is it going to be for them to get their thing licensed with their load following capabilities? Again, I've talked to other developers who are we're going to do load following, but not with the first one, because it just adds a whole nother level of both engineering and regulatory complexity. So I mean, I do think that, whether it's demonstration or commercial, kind of creating economics where you can kind of do the small thing first. Obviously that's what we did with large light water reactors too. They weren't originally large, and we serially scaled them up as we kind of understood better how they worked.
And they also weren't originally very high reliability either, right? They were the fleet in the 1970s was operating at 70% capacity factor or 65% capacity factor, right? Or actually below that even. On load following, I think this is where, maybe once again searching for some disagreement here, I think one of the things that I find interesting is that, we have, the AP1000 can load follow, right? The ABWR can load follow faster, at 1% per second, right? At least between 60% and 100% output, and is licensed to do that. And we see plants load follow in the U.S. Because of bad merchant market design. Quad Cities famously load followed in the late 2010s. I think probably where we do actually disagree is on whether, in fact, the capital economics, are strongly favoring the advanced reactors versus the non-advanced reactors. And and advanced, of course, is a euphemism. It's a marketing term, which means, non-light water reactors, even though the first the first power reactors were obviously all non-light water reactors. And of course, Chris probably, I don't know if you consider CANDU's advanced reactors, but even though they're obviously, have overweight water, water with a heavy problem, with a weight problem. But I think, where my general concern about this, if we want to get into like the actual debating aspect of this, which realize we don't have very much time anymore, but is essentially that in my mind, the experience that we've had with sodium fast reactors, like what TerraPower is trying to build, right? If we look at the commercial history of people who've tried to do it, the Japanese, obviously the French, not successfully, but the Russians really did do this a lot, right? And have commercial fast reactors right now. And if you look at their history, right, their general, when they first started their 300 megawatt demo plant, right, in Shevchenko and now in Kazakhstan, right, they had to scale up the economics overall, scale up the plant power output over and over and over again in order to get the plant to be economical. And they come up to the BN 1200, right, which was supposed to be the one that actually reached parity with their pressurized water reactor fleet, and they stopped construction of it, literally because the Russians back in 2015, and 2018 said they couldn't compete, and I kid you not, with an AP 1000 in project economics. And when I think about having those large history of, these are not, these are state-owned enterprises trying to deploy this technology not over 10 years, but over 50 years, right? The same thing you could say with the British, with the advanced gas reactor fleet, and then the Magnox fleet, coming before it, that a lot of these on paper sort of advantages that I think, non-light water reactors have, sometimes when we try to build them like anything else, it turns out they don't really materialize. And what I worry about here is the opportunity cost, is that I think we do have technology that, to your point, right, we do know that once it gets built, we will have a high capacity factor and pretty good O&M, ignoring the capital costs on the economic side. And do we want to take the choice, between the British and the French, right? Back in the 60s, the British, had the opportunity to go with a light water reactor fleet, standardize it. They choose, an advanced technology, literally called the advanced gas reactor. And then the French, of course, went with Westinghouse and literally just standardized the 3-loop and started minting it out. Now the French are one of the leading nuclear countries in the world, and the British are kind of crawling back to light water reactors in the Great British Nuclear Bake-Off that they're doing right now. And the question that I would ask is, given where we are in the industry, given the sort of lack of political capital that we have, and I recognize that political capital is so important here, and that the policy problems are not de facto easier to solve than engineering problems. In fact, in some cases, the exact opposite, right? Policy problems can be much harder, and I know BTI is really involved in this. Do we think, given that we have finite political capital, that what is the right approach given those constraints?
Yeah, I mean, I actually think we have a lot of political capital.
We do, or we don't?
We have a lot of political capital now.
Okay. Interesting.
Right.
I agree. Thanks to work of like your organization, of course.
It's like it's just like it's like the only thing in the entire U.S. kind of federal system that like still has any bipartisan buy-in on anything. And if you kind of went and looked at like, we've done kind of, serial policy making for nuclear. The biggest challenge right now is just federal money. We've got these tax credits, which I think will survive whatever happens to the IRA, is likely to survive. We'll see what happens with LPO, where, the knives are out for LPO. We've got this, I don't want to burn any bridges, but, we've got this cost overrun bill that just got introduced that, even if you kind of like how they're doing it, it's like $3.7 billion. I mean, that is not, sufficient
I think for 3 projects, right? Or something like that.
Yeah.
Right?
So, and again, this is, not to kind of keep beating this point, but like, if I look at like, what kind of money do I think you can get out of the U.S. Congress right now to sort of backstop any of this? Again, I think kind of having lower sort of project finance costs per unit that you're going to build is a real advantage right now in terms of just the sort of political world that we're dealing with. I don't think we're not going to go do contract for differences like the UK did in this Congress. So I do think that there's, I think insofar, I'm less worried about the opportunity costs and more worried about like anybody putting steel in the ground. And what do we need to do to just kind of get some steel in the ground? Again, I think, the advantage of some of these smaller projects is, for better or worse, like even if they go really badly, the sort of sticker shock is sort of significantly less than, a large light water reactor that runs way over cost. Now, whether that gets us to, where we want to be. And I should say, I also want to like recognize James. And I think, I heard Chris say something where he's sort of like, well, I'm not a nuclear bro. I'm like a recovered nuclear bro. And I will say one, and I will say this because I'm almost certain it's true. I went and actually looked at it. We literally invented the term here. Alex Trembath and I, in like 2016, I think we're the first people to use the term nuclear bro. And we were literally talking about people showing up in our things who are just like, not like just build AP1000s, because that wasn't the flavor of that moment. It was like, go build thorium or go build an IFR. And like literally, and the very first publication that we published was like going and reviewing all the different advanced technologies, light water and non-light water, because we had a bunch of people, including some of our funders, who were like, we don't need to do all of this new innovation. We have the integral fast reactor and it is the obvious solution, and let's just build it. So and actually where we ended up was that, probably, the sodium cooled reactors were not the most likely, place we were going to succeed for some of the reasons that you're mentioning, James.
No, that's a fascinating backstory that I did not know about. I totally agree. Going back a little bit to the policy point, I agree that we're not going to have contract for differences by the federal government. I think basically, or some other sort of federal the ITC and PTC supports are incredibly generous. And, we'll be lucky if they don't get repealed. And I agree with you that they're probably not going to get repealed, especially on the nuclear side of things. The LPO, I'm very worried about. I think the knives, as you said, are really out. And I think that nuclear advocates in general need to be quite worried about this. But going back, I think that to your point that you and Adam made in the Breakthrough Journal, I think that the opportunity that is presented to us by the hyperscalers, you can do a contract for difference, and the counterparty doesn't need to be anymore a government. It can be a creditworthy off-taker who need gigawatts of power, right? If you take Microsoft and Google combined right now are about 6 gigawatts of load, and that's in 2023, right? And that's going to grow pretty fast. And Amazon is already way more than that. Why I'm talking about opportunity costs, I do think that there is a possibility here to get steel in the ground. What I'm trying to figure out is, there's a lot of steel in the ground around the United States of abandoned nuclear projects. Now, to your point, they're all light water reactors, right? So, this is not actually an LWR or non-LWR point, but I do think that we need to make sure that technology that we do develop, once we turn it on, has a viable commercial market that is able to generate power. And that's what I worry about, just putting my cards on the table with the non-LWRs, is that I think the capacity factor challenges here and the reliability challenges here are going to be harder to overcome in an environment where we don't have the AEC spending between $4 and $8 billion a year on reactor development, right? That if we look at the history of Fermi Unit Number 1, Fort St. Vrain, right? These were real commercial problems, right? And General Atomics never sold another high temperature gas reactor in the United States after Fort St. Vrain. And I worry about, and that doesn't mean that technology was, should have been thrown away, right? We see obviously Chinese, obviously on pebble bed, different technology, but continuing to develop that BWXT on the micro side. I worry about what, whether it's non-light water reactors or light water reactors, what are we going to be doing to make sure that either the LWRs get built, and if the advanced reactors get built, that we go beyond the first reactor and get through that valley of death in terms of getting through technology diligencing, regulatory, let's call it normalization. I have no even idea what the right term is, but like rationalization on a regulatory perspective, and actually get to a point where you can get to a high capacity factor and a commercially viable product on the non-LWRs.
The point is very well taken. I do think, and this is like a really hand-wavy point, I'm just going to say that right up front, but I think that what we're trying to do right now in the advanced reactor space, no one has ever done before. And I don't mean that in terms of just the actual technology, but like this is arguably the first like kind of really not state-led effort to commercialize civilian nuclear technology. That one way or another, almost everything, and you kind of go back to all those old AEC projects, you go back to almost every place. These are kind of state-led projects to one degree or another, whether they're kind of big state contracting incumbents or they're literally being done by laboratories, or, in the case in China and various other places, they're literally government, kind of owned enterprises that are doing this. And now, we got Bill Gates and Warren Buffett over here. We got, whatever, every billionaire has their own reactor, but, like startup, for better and worse, sort of, it's a very different business model. They do things really differently. And we're going to kind of find out, I think, fairly quickly here, whether any of it's real, whether these kind of more nimble startup, whatever adjectives you want to put around them, actually can kind of do this differently and better than the sort of various sort of kind of military industrial state-led entities, let's call them, that, to one degree or another, if you go back through the history of literally all of this, are kind of sort of trying to kind of do this new technological innovation. And, like I said, I'll be the first to tell you that it's highly uncertain and that there's a lot of risk. And again, it may all turn out to be vaporware. It may not. And then, we have an alternative model. We understand what the challenges of that are. They're very different challenges, in terms of large reactors. And, maybe that's where we end up. I really don't know. And I kind of know the things that I think, within my own institution and organization, and advocacy that I can kind of do to try to make this other path more plausible. And there's sort of various people working on the other side of that. I wish more of the advocates who are like, shut up with your stupid paper reactor vaporware and just build large reactors would actually kind of come to the table and do the work of actually being like, okay, tell me how we fix the policy. Go find me like a single member of Congress who's going to go like introduce the piece of legislation to do the thing that you say we should do. Because like I've been around, sort of politics and policy making for a really long time. I don't see it now. And if someone can show me a plausible political path and stop telling me I have to do it, because I'm doing the other thing. But I will back it. I will support it. I'm all in. I'm really happy to build as many AP1000s as anyone can convince anyone to build. And I'm happy to support viable, sensible policy to do it if anyone would propose it. That's what I'm still waiting for.
I'm not even sure you need new legislation at this point, right? I think that there's a market formation, market demand issue that needs to be solved on large light water reactors. I do think we need to see LPO, be a little bit more comfortable with the risk profile. I think we do need to see the emergence of actual large light water reactor developers. I want to go back to, and I think there is a real pathway here to get this done. I do want to go back to your point about the large entities versus disruptive. I totally agree. I think one of the biggest problems in the nuclear industry has been that Westinghouse, General Electric, Combustion, Babcock's, Bechtel, Abasco, all these companies were big defense contractors, right? And they have, change order mania, right? Their way of making money has been on cost overruns, right? They make money on cost overruns. And not only do they make money, historically in the regulated utility markets, if you could prove to the PSC that this cost change order was prudent, right? You not only recover that money from the rate base, you make a guaranteed profit, a capital recovery rate. And you can talk to people who are building nuclear power plants in the 1980s where they get yelled at because the few plants that did come on time and on budget, right? They lost their company hundreds of millions of dollars that they were expecting on both sides of the equation, right? On the EPC or vendor, and then also on the utility side, right? Where they're like, at the end of the day, you got through the NRC much faster. Well, we could always get the NRC to be prudent, right? And I don't think
you didn't rate base enough cost overruns.
I literally know someone who had an opportunity for the NRC to slow down their project by a year and a half, and they got through various aggressive tactics, got the NRC not to take that roadblock away, got yelled at because they could have easily gone to the Public Service Commission and said, the NRC forced us to do this, and it's going to be $800 million, and we're going to make $80 million of profit off of that. And this is why the startups, as someone who's just taken a lot of venture capital money just recently, these are why startups are very, very important. And I don't think they're all vaporware. Even in the non-LWR space and the advanced reactor, paper reactors. I think maybe where I get worried about, and I don't think we figured out the business model yet on proving a power engineering technology, is that power engineering, I think, because the whole value that we're selling in nuclear is the always on sort of high capacity factor. If you look at what the mission time of a nuclear power plant is, a component, even in a large or small reactor, we're trying to go for like a 90% reliability over a 2-year-long mission, right? Or maybe even sometimes longer on some of these more advanced reactor technologies. And just, the way that we think about in startups or in software development, this sort of design, build, iterate sort of paradigm, that is based on the idea that we can build a lot of prototypes, run them, and in a short amount of time, get enough failure modes identified, and then engineer solutions around. So if you think about a Falcon, not, a Merlin engine on a Falcon, right? This is has 180-second, 3-minute long mission time that we want to get to 99.9% reliability. And you can run for 50 hours, right? So that you can do the math, that mean time between failures is around 50 hours, which means I can run for a couple of years, a pretty aggressive test program, and I can have hundreds of failures that actually I've identified, categorize the failure mode, and engineer around it. If you think about what just a 90% capacity mission, reliability looks like on a 2-year-long mission duration, that means that I need like 160,000 hours before the mean time between failures. So being able for us to get a policy environment or a financial environment or a fundraising environment that is conducive to getting around these technology development humps is what I worry about in really inventing a new power engineering technology. And it's why even in the gas turbine market, if you look at the combustor design on a modern, large frame gas turbine, it's from the 1960s, or it's slightly evolved, obviously, but it's that they've had that really long amount of tech development time because it just takes that long for these high reliability systems that are operating on a high capacity factor for a very long time require. Once again, I think that this is a problem to be solved, not a reason to stop developing advanced reactors. In the same way that I think, us thinking about what is really necessary for the market and the financing to get a large light water reactor on board, I think these are kind of two sides of the same coin in some ways. And that rather than us bickering about it, I think, it would be better for all of us to think about proactively, what are the solutions that we need to actually get this done on both sides of the equation?
I think that's probably a nice place to wrap up. this has been sort of far more conciliatory. The
We'll
ratings
fight the next episode.
there's nothing like outrage to fuel the clicks. I would honestly like to say that, that it's the medium, and obviously the medium contributes.
Obviously,
Twitter,
you were integral to this entire thing.
I had a huge role. That intro was just incredible, the way it just calmed tensions. But no, I just to be sincere for a second, I think it really does speak to the character of you both, the caliber of your intellect, but more importantly, again, that you're here to have constructive, interesting, civil conversations when the medium provides the space for it. So really, really glad to curate the space in the minimalistic way that I did. And to get you guys, conversing. I think, there are two camps here. There is a battle of ideas. I think there's a lot of productive debate that will come out of these furthering these conversations, and Decouple's very happy to be a place to do that. So thank you again, gentlemen, and hopefully we'll be doing this again sometime soon.
Well, thank you guys.
This was great. Thanks.
Thanks again, gentlemen.